All right, so I wanted to work some of the DeltaMath sections. I got a request to do, let me actually go back real quick to DeltaMath. Equation of the circle 3, equation of the circle 6, and then area of a sector number 1. That's what I'm going to be covering in this video. So I've already got equation of the circle number 3 is right here, okay? So if we imagine a circle, right, and we know that it's on the coordinate plane, we've got this equation here. We know our equation is x minus h squared plus y minus k squared equals r squared. Okay, so on this one, the first thing we know is that the circle starts at the center point. This is 4, and then this is actually -3. You always change the signs when you pull those out. Okay, so there it is. And it tells us that this 29, well, the 29 is not the radius, by the way. The radius would be square root 29. So that's important. But what do we want to do? We want to shift it up 5 units and then shift it left by 6 units. So we would grab our circle, go up and then left. So what would happen to this circle? Well, we're going to transform these x values. So if I shift it up, that's going to modify up 5 units, modifies the y value. So the y value goes from -3 to 2. And then if we go left by 6 units, that's going to change the x value. We're -6, so it's -2. So we know that in our equation, remember, you change the sign when you put it in there. So it can't be this one, or this one. It has to be one of these two here. So here's where a lot of students are making the mistake. They are doubling the 29 because it says then its radius is doubled. They're doubling the 29, but that's not what we need to double. We need to double this right here. And that kind of gives away the answer if you see what I'm saying here. We now know, but let's explain that. So double the radius equals 2 times square root 29. Okay? So then what do I do with that value when I double that radius? Well, then I need to square it. Okay? So I square this, and when you square this value, you're because these are being multiplied, you're able to distribute this square to both of them. And what happens when I square 2? Well, I get 4. And it's going to be multiplied still by this square root 29, but the square root goes away because it's an inverse, right? Now 4 times 29 is 116, so that's why this problem, the answer is this one here, okay? So that's number 3 on there. Next, let's get equation of the circle 6. All right, so we have a square with length 2, and it's sitting in the first quadrant with 1/4 corner touching the origin. So let's draw some XY axes. Here's X. Okay, that's Y. Here's X. And we're going to draw a square centered at the origin. So let me get a little tool here. Here we go. Square. Perfect. All right, so I'm going to draw I wish it was hollowed out. Hold on. Build. I guess it doesn't really matter. Oh, there it is. Okay. So a square. Boom. There we go. Pick that up. And the square is going to go right here. And it says it has a length of 2. Right? So the length is 2. And that goes all the way around. So we know that this point here is 0, 2. Point here is 2, 2. And this point here is 2, 0. All right, so we've got that square. Now, it says if the square is inscribed, so that means we've talked about like inscribed angles and things like that. That means every single point of this, every single vertex of the square has to go through the circle. So we imagine, let's imagine that the center of this circle is here. Now this isn't going to be perfect, I don't think, but imagine that, and then we draw this here, close we get. It's not bad. It could be better. But imagine that's what this is talking about. I could do a better job constructing that with GeoGebra, but that's fine enough for what we need. Anywho, that's the idea here. Okay, so what is this point here? Well, it has to. We're going to go up and over like so. Let me actually. Let me actually undo that. Use some dashed. Let's use some lines here. Dash. Okay, so we are going to go over and then up. Sorry, let me make those over. So you have this change. So it's going to go over one, up one, and we know that this point should be 1, 1. It should be. Okay. That should be that coordinate. So we know right away that when we're looking at these options on here, it wouldn't be this one. It couldn't be positives. We're not going to have any positives. So really we're between these two here. And so what we really need is the radius. So what is the radius of this? Well, the common mistake is to say that it's 1. Because if I draw this radius here, we know that this is 1 and 1, and if we want to find that distance, we can use Pythagorean Theorem. It's 1 squared plus 1 squared equals our radius squared. Okay, so when we add these together, we're going to get 2 equals r squared, and that means that r is just going to equal square root of 2. All right, so that's actually what the radius is. It's square root of 2. But when we square it and put it into the equation, so when I square this, I go back to this, so we know that it's got to be 2. So it's not this one. It has to be the 2 there. And I think that's where a lot of students are getting confused on this. Okay. All right. The last one that I want to work is this area of a sector 1. So again, we have a circle named C centered at the origin. Go ahead and make some more axes here. Circle is centered at the origin, and it has an area of 16. Let's move this here. All right, here's our circle. Boom. And it says we want to find. It says this circle has an area of 16. The total area is 16. Now, it says, what is the area of the sector defined by the lines y equals x and the x-axis? Well, this is the x-axis, right? What does y equals x look like? That's a line with a positive slope. The slope is 1, so it's going to go rise 1, run 1, right? This would be what it looks like. This is y equals x. Okay, y equals x. So if we look at this, we have to figure out, because this is sector area. Remember, our formula for sector area is theta over 360. It's a very bad theta. Hold on. Theta over 360 times, and really it's just this times the area formula. So pi r squared. Now, do we know what the area of this circle is? This part right here? Yeah, we do. It's 16. Okay, it's 16. And really all we need to know is, because we have the 360 here, have 360. What is theta? So what is this angle right here? That's what we need to know. Now, it may not be common knowledge what this is, but I think everyone knows the angle created by the x and y axis, right? They're perpendicular. So the x and y axis are 90-degree angle. So what about this y equals x? Well, it's a 1-to-1 ratio, right? Or a change slope. It's 1-to-1. And so that's going to split it right in half. So this angle, 45 degrees. So we know in our formula, when we write this up, I'm going to put 45 here. So we pull up the calculator and we get 45 divided by 360. And we want to multiply that by 16. So we get an area of 2. Okay. Hopefully that was helpful. If you have any more questions, let me know.